Hey there, how you doing, year ones? We are looking at connected particles. I'd love to be doing this with you, but instead I'm going to kind of do it at you. This is the first question on the connected particles sheet, which it brings together the last few topics that we've looked at. We are going to have F equals MA at some point, and we are going to use suvat. So these are quite big, meaty questions. I'm going to use everything that we've done recently. So this is two particles. Their masses are 2 kilograms and m kilograms is marked, where B is, so the mass of B is less than 2. So that already tells you what the system's going to do when you release it. They're connected by a light inextensible string, which passes over a smooth fixed pulley, so no friction anywhere in this system. A is 3 meters above horizontal ground, and the string is released from rest. The string taut and everything vertical. So a simple system. So looking at that, what we have to do first of all is, in our imagination, imagine what is going to happen when we release this system. If A is the heavier particle, then A is going to move down, as it says, it's going to hit the ground after 2.5 seconds, and B is going to get dragged up towards the pulley. It's also telling us that B doesn't hit the pulley before A hits the ground, so nothing gets in the way of A's progress. And then we've got 3 questions. A is finding the acceleration of particle A, finding the mass of particle B, and then just a little common sense question at the end. So let's crack on with that. First thing to do whenever you get one of these, whether or not they've given you a diagram, is to draw a diagram. Nice big one. This you could write on the sheet if you've printed it, but if not, draw yourself a diagram. Okay, then we're going to put on all the forces going on there. Now, for part A, if we look back at the question, I suspect for part A we're not going to need to look at forces yet. So we might well need F equals MA for the second part. But I think what we might have there is, we've been given in the question 3 meters, so a distance. They've snuck in this from rest, so we've got something about its initial velocity there from rest. So it's still when we start, and it's got a time in there. So distance, speed and time, I'm thinking suvat is going to help us, and if it doesn't, it might be useful later. So for part A, if we're finding acceleration, I'm going to have a look at what the suvat equations give us and analyse it like that. So although we've got our diagram ready to put the forces on, first part of this question, we're going to go with suvat. So we want to find the acceleration. So with any suvat equation question, have your suvat down. Which ones do we know? Well, the S is the distance or displacement. We do know that. It's going to drop exactly 3 meters. Do we know U? That's its initial velocity. Well, that's snuck in there with that system being completely at rest at the start. So yes, we do. Actually, it's at rest at the beginning. By the way, anytime you think you can just run on with this, pause the video or stop it and have a go. V, now that's the final velocity when it hits the ground. That's going to be not very helpful to us here. I think that might be the one that we don't need. You can always leave it blank and have a look at the others. A is what we're trying to find. So let's just call that A for now. That's our desired part. And T, do we know how long it's going to take? We do. It says 2.5 seconds is how long it's going to take to hit the ground. So this is classic suvat. Remember, we've got 5 equations, and each one has 4 variables in it. And we have S, we have U, we want A, and we want T. We have T. So we need the one that has no V in it. So get your suvat equations out, have a look at them. And actually the one that has no V is this one that we use quite a lot. Quite a common one to use. S equals ut plus a half at squared. And then we'll just substitute in. So what we get is 3 is equal to, oh well, we've got a naught for u, so that whole bit's going to be naught, plus a half. A is the unknown, and t is 2.5 seconds. So we just substitute all that in. So if I do a little mess around with that, 2.5 squared is 6.25. You can check that on the calculator if you like. Let's get rid of that half. So 6 equals 6.25a. So I've just doubled both sides. Got rid of the half. Multiplied that by 2. And so a, well, you can do this however you want on the calculator or whatever, is that, which looks about right. It actually comes out as 0.96 approximately meters per second, which is what they want in the question. So that part A is just a suvat equation using the information given. Okay, at part B, the 7 marker is finding the mass of B. Now if we're talking mass, remember suvat, there's no M in suvat. I'm going to end this video here, but if you want to see part B, tune back in. Next video coming.